Okay, so here's the thing from the video where we'll check the math. So he said if x is a sum of two squares and y is a sum of two squares, then the product is also the sum of two squares. So he just stated this. So I thought it would be good algebra practice to try to check this. So what do you think you'd do?
Well, first you could just see what multiplying these things gets you.
Okay. And what is that going to get me? X times y equals
a squared times c squared.
A squared c squared.
Plus a squared d squared. Plus b squared c squared. Plus b squared d squared.
Okay, so that looks pretty complicated. Do you see any hope for why this expression might be equal to these two sums?
Well, we have all of these squares. We can see them here. We have the a squared c squared, the b squared d squared, the a squared d squared, and the b squared c squared.
So we have all the different terms.
We have a few other intermediate things that might have to be canceled out.
Okay.
So, I think I can kind of see how they do this. Because each of these equations is going to have a 2 a, b, c, d in them. But this one has a minus 2 a, b, c, d, and this one has a plus 2 a, b, c, d.
Okay.
So basically, to go from here to here, you add and subtract away a 2a, b, c, d in this expression, and then you simplify into two squares like this.
Do you see that?
Yes.
This when you multiply this out, you get a squared c squared minus 2ab cd plus b squared d squared.
And you have these terms here.
Yeah.
And then you do the same thing. You get a squared d squared plus 2abcd plus b squared c squared.
Yeah.
So then you have all the terms.
Yeah, and you get this miraculous cancellation. But he said there was also a second way you could get it as the sum of two squares. What was that way?
Well, you could flip the signs.
That's exactly right. You just want that minus 2abcd, so you can get it from this one, or you can get it from this one. So you can flip the signs. Which means that it looks like if x is a sum of two squares and y is a sum of two squares, then x times y is the sum of two squares in two different ways. What does that mean about x times y?
Well, it's not prime.
Yeah. Could we have known that already?
Well,
I
by
mean,
multiplying
x
two
times y
numbers
is
together.
Product of two numbers.
So it's
Unless one of them is 1.
right. Is 1 the sum of two squares?
It is not.
Not a positive.
Mm-hmm.
So let's maybe just do an example of this, because we should be able to pick two numbers that are pretty easily the sum of two squares. So 5 is 1 squared plus 2 squared. And 13, that's
It's 2 squared plus 3 squared.
2 squared plus 3 squared. So that says 5 times 13, which is
65.
65. Well, first of all, can we write 65 as the sum of two squares?
Yeah, 1 squared plus 8 squared.
1 squared plus 8 squared.
Or I saw 7 squared plus 4 squared.
Nice. Okay. So A, B, C, D. So AC is 2.
Yep.
BD is 6. AD
3.
3. BC is
4, so...
3 minus 4 squared. So this is our 8 squared
Yeah, it's the 1 squared.
plus 1 squared.
And then you
And then if you
could...
flip the signs, you get the 4
Yeah.
squared plus 7 squared.
So if you flip the sign, you get 3 plus 4 squared and 2 minus 6 squared. So yeah, so 4 squared, 7 squared. Cool.
Yeah.
All right. So what we're going to do off camera now is we're going to write a computer program that tries to find all the different ways to write a integer, any integer, as the sum of two squares.
Okay.
And we'll see what we find.